Hello everyone. Now we are going to learn about putting them together inequalities and absolute value. You know that in the previous videos I have discussed about inequalities as well as the absolute values. Now we will calculate this inequality and absolute values together. So how can I calculate this inequality and absolute value together? The answer is here. Some problems on GRE include both inequalities and absolute values. That means in GRE question, you will find some question that inequalities and absolute value will be combined. You can solve these problems by combining what you have learned about solving inequalities with what you have learned about solving absolute value. That means you know how to solve the inequality, you know how to solve the absolute value. By knowing this both, you can solve these types of example. Now I am going to solve this example. So firstly, they have written that even though you are now dealing with an inequality and not an equal sign, that means look, you are dealing here with, suppose this one is something like this. So here you are dealing with inequality, not the equal. The basic operation is the same. That means the operation was something like that to isolate the which one variable. The absolute value is already isolated on the one side. Look at this is quite easy because in this inequality already this x is isolated. That's why they have written that already isolated in one side. So now you need to set up your two equations, or in case the inequalities, you need to set up two inequalities or equation here. First one is here, look, for this one they have given not x equals, they have given modulus of x. So you know this from my previous video. I have mentioned that modulus of x, this means it can be plus x, it can be minus x. That's why from here, modulus of x greater than or equals to 4. What does it mean? It means x greater than or equals to 4, or either or minus x greater than or equals to 4. So if I write x greater than or equals to 4, this is here. But here this minus, I need to isolate the x. But here you will find that x in front of x, there is a minus sign. To remove this one, you need to multiply with minus 1 in both sides. So here this one will be minus 4. But whenever you know this, whenever you multiply with any minus sign, minus number, negative number, in that case you need to transfer this, you need to rotate the sign. So this one is now less than or equals to. Okay, so our one value is x greater than or equals to 4, another one is x less than or equals to minus 4. Okay, so now you have two equation. First one is this one and second one is this one. Okay, I set the variable. So this one is our one answer, another one is this one. So they have written. So if I draw this, suppose x greater than or equals to 4, what does it mean? Suppose this is our number line and here you are finding, suppose here you are finding 4. Okay, and here you 0, 4, 8. I'm taking the values after 4 steps. So that means equals to 4 means you need to fill up this circle, and greater than 4 means in this side. So our answer will be this one. As well as x less than or equals to minus 4. What does it mean? Suppose here you are finding 0, this one is minus 4, this one is minus 8. Okay, this one is minus 8. So what you will find here, minus 4 and the equal sign, that's why you need to fill it out, and minus 4 less than minus 4 means in this side. Okay, so if I combine this one and this one together, then what will be our answer? Our answer will be something like this. Suppose this one is 0, this one is minus 4, and this one is plus 4. So from plus 4 to right hand side this way, from minus 4 to left hand side this way. So our answer will be this one. So they have drawn the same thing here. So now I'm going to read out this. As before, any number that is covered by the black arrows will make the inequality true. Here the black arrows in the right side as well as left side. If you place the value, suppose if you place any value here from this bold line, then this will be true. Suppose here you will find a value 5, 6, 7. Place here 5, 6, 7. 5 is greater than 4, 6 is greater than 4, 7 is greater than 4, but only 4 is equals to 4. Similarly, if you take any value from here and place it here, then it will be true. Suppose you are placing here -8. -8 is -8 is less than -4. Yes, it is less than -4. That's why it is also curved. But only -4 is equals to -4. Because of the absolute value, there are now two arrows instead of one. Because whenever we deal with only this equality, you have only one arrow. Only this inequality, you have only this arrow. But whenever I am deal with this one, modulus, this involve this one as well as this one. That's why whenever you discuss with this modulus, then our answer will be something like this one. Okay, so else has any number to the left of -4 will make the inequality true, as well as any number to the right side make the inequality true. Okay, the same thing I have discussed. Looking back at the inequality x modulus of x greater than or equals to 4, you can now interpret it in terms of this one. That means x is at least 4 units away from 0, because this is modulus of x greater than 4, and either in direction the black arrows indicate all the numbers which is segment is 2. So in your case, whenever you solve this types of equation inequality, you must follow this process. Just learn this thing, that modulus of x or modulus of any variable equals to plus of that variable as well as minus of that variable. Okay, now going to the next one, example number 2. So example 2, what they have written, modulus of x plus 3 less than 5. So first from here you will find modulus of x plus 3. One will be positive value, that's one will be something like this one. One will be negative value, minus x plus 3 less than 5. So if I calculate this one, this plus 3 is transferred in the right side. That's why it will be plus 3 minus plus 5 minus 3. That means x less than 2. Similarly, if I transfer this minus sign in the right side, then my sign will be reversed. So x plus 3, this less than sign will be greater than sign, and this will be minus 5. Now my answer will be something like that. X, this minus 3, if I this plus 3, if I transfer in the right side, then it will be minus 3. So x greater than minus 8. Okay, so our answer will be x less than 2. Another one is x greater than minus 8. So look at this. So once again, the absolute value is already isolated on the one side. Look, this is isolated. Just you need to transfer this 3. Now, so now you need to set up two inequalities. Of course, I have set up this one and this one. The first inequality, replace the absolute value with the positive. Yes, I have taken here positive value. And the second, replace the absolute value with the negative. I have taken here negative value. So this one is first one, this one is second one. As for me, this one is first one, this one is second one. Now go to the next one. So if you notice this one, then next the isolate the variable. Just you need to find out the value of x. So x less than minus 2, and here x greater than minus 8. Our answer will be something like this, x less than minus 2 as well as x greater than minus 8. Now it's time to draw this in number line. So x greater than x, first one, x less than 2. What does it mean? Suppose this one is 0, this one is 2. So less than 2 means first draw here, but here there is no equal sign here. That's why you don't fill up this circle. Just draw in this manner. Okay, just draw in this manner. Similarly, x greater than minus 8. So suppose this is our number line. Here you will find 0. Here you will minus 8. Sorry, this one is minus 8. Suppose this one is plus 8. So first you need to draw a circle here, and minus 8 is greater than minus 8 means this side. But you cannot fill out the circle because this is not equal. That's why our answer will be like this. But if you compare this value in one sense, like that, x in a one sentence, look, x is less than 2 means the value is the left side, and x is greater than minus 8. So our answer will be the combination of this one and this one also. So how can I combine these two? Look, what is the common thing here? The value is started from, look here, the value is started from minus 8, and it will end up at 2 in front of 2, and it will start just below from the just next from the minus 8. So if I draw here minus 8, and sorry, if I write here minus 8 and if I write here 2, so this is 2, this is 8. no circle will be filled out because here no equal sign is given here. So our answer will be, the common thing is, look at this. So minus, from minus 8 to 2, minus 8 to 2, our answer will be something like this, minus 8 to this portion only. Okay, minus 8 to 2. So they have given. It seems like every number should be solution to the equation. But if you start testing the number, it isn't the case. Test x equals to 5. If you take look from this case, suppose our question is something like that: the modulus of x plus 3 less than 5. So modulus of x plus 3 less than 5. Suppose from this inequality, this one, so x greater than minus 8, any number, take, suppose take a number which is greater than minus 8. Here they have assuming 5. Now place this here, 5 plus 3 modulus this one and 8. So if 8 modulus of 8 means 8, is it true? No, it is not true. That's why you need to take common here, common portion. Here the common portion is this one. So they have written, for example, is 5 plus 8 less than 5? No, it is not. As it turns out, the only numbers that make the original inequality true are those are the true of the both inequalities. Means I need to collect, I need to select some numbers which satisfy the both inequality. That's why I was saying that you need to take the common portion. So reality, your number should lie this way. In first example, it was the case that x could be greater than 4 or less than minus 4. For example, however, it seems make more sense to say x is greater than minus 8. Yes, the same thing is written here by giving the common, by taking the common. Now the inequality you just graphed means x plus 3 is less than 5, right sir, from 0 in either direction. The shaded segment indicates all the numbers x is true. As the inequality becomes more complicated, don't worry about the interpreting and meaning. Simply solve them algebraically. Looks, whenever you find any complex inequality, suppose here they have just only given addition, but if it involves addition, subtraction, multiplication, division, just try to solve. Whenever you solve any algebra or algebraic expression, try to solve this inequality like that manner. And lastly, you need to find out the common thing, that for for inequality, you know that you will find two inequalities, this one. Then you need to figure out the comparison. You need to compare these both and find out the common thing. Okay. To summarize, when representing inequalities on the number line, absolute values expressions where variables are greater than some inequality will show up at two ranges of opposite direction. Yes, double arrows. Yes. However, absolute value expresses where variables are less than some equality will show up a single line. So they have written that in inequality you need to show that two direction, in two directional, because look here, one direction, another direction. But for the modulus or for the absolute value, you don't need to show the two direction, because for modulus or one direction you just only a single branch.